Hi, it's Mrs. Mafucci, and this is the second video in our series of solutions. In the first video, we looked at how substances dissolved. We looked at the process of dissolving. We looked at the difference between ionics and covalents and how they dissolve in solvents such as water. Well, let's now see if we can answer this question. How can I get sugar to dissolve faster in my iced tea? Well, probably you would say stir, stir, and stir. Stirring would definitely increase the rate at which sugar dissolves. What about if I added the sugar to warm tea and then after it dissolved, add the ice? And lastly, what about if I grind the sugar cube into a powder? These are three methods of speeding up the rate at which a solid dissolves: stirring, increasing the temperature, and grinding the solid into a fine powder. Well, let's look at how each increases the rate of dissolving. Number 1, temperature. As temperature increases, the rate of dissolving or the rate of dissolution increases. Temperature affects the speed at which particles move, and as temperature increases, the kinetic energy of the particles increases. Dissolving depends on the collision between solvent and solute particles. Therefore, when the particles are moving more rapidly, there are more collisions and harder collisions. Therefore, the rate of dissolving will increase. Number 2, particle size. As the size of the particle decreases, the rate at which it dissolves increases. Large particles take longer to dissolve than smaller particles of the same substance. Therefore, since dissolving requires collisions between solvent and solute, smaller particles have more surface area for the solvent particles to collide with. This increase in surface area results in more collisions between the solvent and the solute, and the rate of dissolving speeds up. And lastly, number 3, mixing. More mixing increases the rate. Stirring a solution will increase the rate at which a solute dissolves because the stirring increases the collisions between solute and solvent particles. Let's now look at heat of dissolving. What happens to the temperature when a solute dissolves? In an exothermic process, heat energy is released to the environment when the solute dissolves in the solvent. Therefore, the temperature increases. Number 2 is endothermic. This is when heat energy is absorbed from the environment when the solute dissolves in the solvent. In this case, the temperature decreases. In our previous video, we talked about the solubility of solids in liquids. Solutions can also be made up of liquids in other liquids. Two liquids that are soluble in one another are said to be miscible. Vinegar and water are miscible in each other. Both acetic acid, which is the main component of vinegar, is a polar molecule. Water is also a polar molecule. Polar molecules dissolve in other polar molecules. On the other hand, you know that oil and water do not mix. If two liquids are not capable of being dissolved in one another, we say that those liquids are immiscible. Oil and water do not mix because their molecules are different. Oil is a nonpolar liquid. Water is a polar liquid. Nonpolars do not dissolve in polars. Polars do not dissolve in nonpolars. Remember, a polar molecule is one in which there is a positive charge on one end of the molecule and a negative charge on the opposite end. Remember, water has a slight positive charge on each hydrogen atom and a slight negative charge on the oxygen atom. Oil, as a nonpolar molecule, does not have such charges. Let's now consider the solubility of gases in liquids. In general, the solubility of a gas in a liquid depends on the pressure. As the pressure increases, the solubility of a gas in a liquid increases. And as the temperature increases, the solubility of a gas in a liquid decreases. In order to increase the solubility of a gas in a liquid, number 1, increase the pressure, and number 2, decrease the temperature. Let's now look at colligative properties. So find in your reading strategies where you took notes on colligative properties. When a solute is added to a solvent, some properties of the solvent change. These properties depend on the amount of solute dissolved in a solution. For example, if salt is added to water, the vapor pressure decreases, the boiling point increases, and the freezing point decreases. Let's look at each one of these colligative properties separately. The figure on the left represents pure water. When a flask of water is stoppered, creating a closed system, the liquid water will evaporate. But the lid prevents the gas particles from escaping. Therefore, gaseous water vapor will condense. This represents a system at equilibrium, when the rate of evaporation equals the rate of condensation. This equation represents the equilibrium that occurs when water liquid changes into a gas and then water gas changes back into a liquid. The gaseous water vapor particles trapped inside the flask collide with the walls of the container, creating a pressure. The pressure exerted by a gas above its liquid is defined as vapor pressure. Well, what happens if a solute is added to water? The flask on the left represents the original flask. Notice that there are only water molecules in that flask. That's the pure solvent. In the right flask, we have added some solute, represented by the blue spheres. The rate of evaporation is lower in the right flask because of the solute particles. The solute particles take up space at the surface, reducing the number of solvent particles at the surface. This, therefore, decreases the rate of evaporation. And since the rate of evaporation decreases, the vapor pressure decreases because there are less gaseous water vapor particles above the liquid. At this point, I think it's important for us to see the difference between evaporation and boiling. They are not the same thing. So what is the difference between boiling and evaporation? Evaporation occurs at all temperatures. It is a slow process. It occurs only at the surface of the liquid, and no bubbles form. Boiling, on the other hand, occurs at the boiling point temperature. It occurs throughout the liquid, and bubbles form. So let's now see the relationship between rate of evaporation and boiling point temperature. When a solute is added to a solvent, the vapor pressure decreases. This means that the boiling point will increase. Since the presence of dissolved solute particles in a solvent makes it more difficult for the solvent to evaporate, it makes sense that more energy is needed to get those solute particles out of the way to become a gas. Therefore, the boiling point temperature increases. The more solute particles dissolved in a solvent, the greater the increase in the boiling point temperature. And the last colligative property is freezing point depression. When a solute is dissolved in a solvent, the particles get in the way and make it difficult for the solvent particles to form the strong intermolecular bonds necessary for it to solidify. This is why in the winter, if you go up to Lake Tahoe and there's snow and ice on the ground, they will add salt to the roads to decrease the freezing point, which means that the ice will melt because it actually has to be colder in order for the water to be a solid. This also explains why it is more improbable for oceans that are salt water to form ice than it is for fresh water to form ice.